Hello everyone, welcome to watch our video. Look here, our lesson today, as you see, is talking about the transcendental function and the chain rule. How to find the derivative of a composite function. The outer one is the trigonometric function or transcendental function. Transcendental what function. Look here, I have to apply this rule. Here, as you see, the derivative of sine u, it will be cosine u. The derivative of outer, multiply the derivative of inner, as you see. Okay, what is the derivative of sine? Cosine. Here I find the derivative of outer at u or of u. The derivative of outer of u multiply the derivative of u. The inner function here, as you know, it is the angle. I told you before the inner function, okay, maybe in denominator, maybe under the root, between the bracket, and also the angle of the function. The derivative of tan u, it will be, what is the derivative of outer? Secant square u. The derivative of outer of u, okay, multiply the derivative of u. Derivative of secant, it is what? Secant u tan u, derivative of the angle. Please study well this rule, okay? And you have to know how to apply it as I'll show you. Derivative of cosine u, negative. Sine u, u prime. Don't forget u prime. Cotan u, it will be negative cosecant square u. Cosecant u, it will be negative cosecant u cotan u, multiply the derivative of u. As you see, all of that trigonometric function, which has a particle, its derivative has a negative sign. The derivative of natural exponential function, it is what? Natural exponential function of u multiply the derivative of the exponent, because the inner function in this case, it will be what? E to power u. That is the inner function. As you know, that is the outer function. In this case, it will be what? E to power u, it's a derivative e to power u. Okay, multiply the derivative of the inner function, it will be u prime to find the derivative of this natural exponential function. Now I'll show you how to apply these rules. Okay, let's begin. Applying the chain rule to transcendental function. Transcendental what? Function. Look here, I'll use this. Okay. I have to identify where is the angle, where is the inner function. Because as you know, the derivative of function f of u, as you know, okay, its derivative, it will be what? Sorry. The derivative of outer of u multiply the derivative of the inner. So in this case, I apply the rule. Where is the u? Where is your angle? That is u. I have to identify where is the angle. Okay, so what is the derivative of this one? Imply the derivative of this function. It will be derivative of outer. What is the derivative of sine? Cosine, but of u, which is 2x. Okay, multiply the derivative of u, the derivative of the angle. The derivative of the angle multiply the derivative of the trigonometric function, which will be what? 2. Right between two brackets to avoid any careless mistakes. It will be 2 cosine 2x. Okay. Here, as you see how to find this one, it is a composite function. The outer one cosine, the inner one is the angle. Is what? The angle. The derivative of this function, it will be, what is the derivative of cosine? Negative sine. What is the input of this derivative? It will be what? The u, the function u. Multiply the derivative of the angle, which is what? 1 can be submitted. It will be negative sine x minus 1. I hope it is easy. This one, how to find the derivative of natural exponential function. Yes, it's so trivial. I just apply the rule. It will be the natural exponential function multiply the derivative of the bracket, which is, sorry, the exponent, which is what? 3. I prefer to write the number than 3 to power x. That's, I think, trivial. Try to enjoy when you solve like this problem. Here, parentheses and a trigonometric function. I have to know where is the bracket, because at the bracket, at the position of the bracket, I identify which way or how I find the derivative. Look here. Please focus. As you see here, we can write any angle like this one, cosine 60, for example, degree. I can write it between bracket, or I can write without any bracket. In this case, I can write the angle without bracket or as a bracket. Okay, but here there is no exponent, exponent 1, okay? If we have like this one, cosine 3 between 2 bracket multiply x squared. But here I have to show you how to find the derivative first. The derivative of outer of u, which is a negative sign. What is the input here? It will be u. Don't forget, the input is what? U. Multiply the derivative of the angle, which is 6x. Derivative of what? Angle. It will be negative sign first, then the variable and number variable, sine 3x squared. That's all. In this case, miss, as you see, cosine 3, cosine any trigonometric function of a number, it will be constant. Like, for example, cosine 60, it will half. It is what? Constant. But if we have a function like 3x, in this case, it is a constant. Okay? So in this case, I'll apply what? The power rule. What is the power rule when we find the derivative of any power function? Like what? X to power n. It's a derivative. N x to power n minus 1 multiply. What? No, without multiplying. That is because it is a power rule, not a general power rule. Okay? This is when we find the derivative of a term, not a bracket. Understand? So it will be 2 multiply this constant. That is what? Constant. It will be, the derivative of this function, it will be 2 multiply this constant, which is 3. Okay? Multiply what? X. Understand? I can write by this way. Keep it between 2 brackets. Why? If I write, look with me here, cosine 3x by this way, it means that is my angle. But if I'm talking about 3x, it will be cosine 3. I have to write the brackets between, write cosine 3 between 2 brackets to avoid any mistakes and write the function well or the derivative well. Look here, miss. The bracket here, my angle here, it will be this bracket which raised to power 2. Which raised to power 2. I have to distribute the outer exponent on the inner exponent, that it will be cosine 9, 3 to power 2, 9, x to power 2, it will be x to power 2. Here the brackets, what between this bracket? The angle, which raised to power 2, I have to expand this bracket or distribute the outer exponent on the inner exponent and write the function in this way. Okay, what is the derivative? Miss here, it will be the derivative of outer, negative sign of u, 9x squared, between 2 brackets. Don't forget, multiply the derivative of u. Okay, it will be 18x. Then we write the function to be in the simplest form, negative 18x sine 9x squared. I hope you understand. This case, please be careful. When we write tan power 3x, here the power on the word tan, on the function, okay, not on the angle, but here the power on the angle. I think here's the power of the angle. But here I can rewrite it to be in this form, tan x all to power 3. Okay, cosine square x. I can rewrite it to be cosine x all to power 2. Look here, since the exponent above the word or above this function, I can write it like this way. In this case, I have what? Bracket raised to power. Bracket raised to power, general power rule. I have to know when we apply each one of the rule. When we apply this rule or this rule or this rule, if we have a bracket raised to power, I know it is a general power what rule. Look with me here. Okay, I apply it. Why? The derivative of this one, it will be the power or the exponent to multiply cosine x. I have not finished the answer. I have to multiply by the derivative what inside this one between two brackets, which is negative sine x. It will be, as you see, negative 2 sine x cosine x. Okay. Please, you have to know or study well the differences between the bracket. If the bracket between cosine number, it will be constant. Sometimes I can write the angle between two brackets, sometimes no. If we have an exponent, okay, of cosine or tan or sine, I can write it as a bracket raised to power. Okay, clear all? I will not solve number example 12, which is in your book. After I give you some practice or practice on the derivative of transcendental function, okay, I'll show you, or I solve with you this example. Okay, let's solve this problem. So trivial. Look here. Here he asks you to find the derivative of this function. Okay. How to find it? It is a composite function. Since here the angle, not x only or theta or any symbol, it is a composite function. Apply the rule. Keep the rule with you when you solve. The derivative, it will be the derivative of outer negative sign of u, which is 4x. Okay, like I have to do by this way. Multiply the derivative of the angle, which is what? 4. Then the answer, it will be negative 4 sine 4x. Okay, here, how to find this one? Where is u? Where is your angle? U. I have to identify where is my angle. Okay, so the derivative here, apply that chain rule. The derivative of outer, which is cosine, what? U by x. Multiply the derivative of what? U, which is a pi. Pi is a constant, which is 22 over 7. Please keep the rule with you. Because someone will tell me, Miss, from where you get cosine pi x? Because the derivative of sine is cosine. U. Here, the derivative, I apply the chain. Derivative of outer of inner. Then the derivative of inner with respect to x, as you see, it will be pi cosine pi x. Clear? I think it's so easy. Here, this is the next one. That is a chain rule. I'll apply chain rule. The derivative of function g of x or g prime of x, it will be the constant multiply the derivative of this function. What is the derivative of tan? Secant square of, what is the function here? U. That is my inner function, 3x. Okay, multiply the derivative of, don't forget to multiply by the derivative of angle. What is the derivative of this angle or the inner function, which is the 3? Then multiply this number with this number. It will be, don't multiply 3 by the angle, because all of these package together, okay? It will be 15 secant square 3x. Okay, never to multiply a number by the angle, because it is the input of the function. It is the input of what? The function. Look here, where is u? Yes, that is u, that is my angle. Implies the derivative or h prime equal. Here, what is the derivative of secant? Secant tan, okay? Secant what? U, which is x cubed. Multiply tan what? U, which is x cubed. Don't forget to multiply by the derivative of the angle, which is 3x squared. I prefer to write the number, the variable, then write the trigonometric function, x cubed. Here's the cube, the cubic here of angle, not the trigonometric function, okay? Tan x what cubed. Clear? You have to know this exponent of what? The exponent of what? This power of what? Of angle or function. Please concentrate. Okay. After I finish this exercise, I show you how to apply the chain rule many times, or repeated application of the chain rule. Look here. Can you see this problem? I think I showed you. You can tell me, I can rewrite this function, yes. The power here of the angle or of the function? Of the function, but here's the power of what? The angle. Here I can write this function to be in this what? 4. All to power what? 2. In this case, it is what? Power, general power rule, bracket raised to power, general power rule. Bracket, look here, bracket raised to power. Okay, it's a derivative here, the bracket. It will be nu n minus 1 multiply u prime. I just apply. Find the derivative of the bracket. Here, sorry, f of theta. I have to find the derivative of the bracket, multiply the derivative what inside the bracket. But you will see, maybe I repeat the application of what chain rule. I'll show you. Here, what is the derivative of the bracket? It will be 2, okay? Multiply the bracket, decrease the exponent by 1, it will be, multiply the derivative what inside the bracket, but what inside the bracket? It is a composite function, okay? It is what? A composite function. Find the derivative of this composite function. What is the derivative of this function? Here, that is u. Yes, I know. It will be the derivative of outer of u multiply the derivative of u. Derivative of tan, it will be what? Secant square. What is the input? U. Multiply the derivative of the angle, which is what? 5. Again, Miss, as you told me, the derivative of this bracket, it will be what? I find the derivative of the bracket, multiply the derivative what inside the bracket. But when we find the derivative of the function between the bracket, it is a composite function. I'll use the chain rule again. Derivative of the outer secant square of u. Multiply the derivative of what? U. Then simplify, multiply the number together. This function, 2, multiply this function, multiply this function, multiply. Never and ever to multiply this number by the angle, because that is the input of the function. I don't do any operation on it in this case, as you see. It would be 10, 5 theta, okay, multiply secant, or 6 square, 5 theta. That is my answer. Okay, I solved the following exercises, but please pause the video, then solve independently, okay, without any help. After this, play back the video and correct yourself, okay? Look with me here. Miss, again, the same idea. The power here on the function. So I can rewrite the function as cosine 8 theta all to power 2. Since we have a bracket raised to exponent, I'll apply the general power rule. Find the derivative of the bracket, multiply the derivative what inside the bracket. But the function which between the bracket, if it is a composite, I repeat what? The chain rule again. Derivative of outer, multiply the derivative of what? Inner. The derivative of theta, g of theta, it will be exponent. Yes, perfect. I see some of you can solve with me. Cosine 8 theta. Decrease the exponent once, one can be submitted. Multiply the derivative what inside, but it is what? Composite function here, that is u. The derivative of outer, it will be negative sign, please write between two brackets, u. Multiply the derivative of u, which is what? 8. So it will be 16, but please don't forget the negative sign. 2 multiply negative, multiply, it will be negative 16. Cosine 8 theta, multiply what? Sine 8 theta. Okay, that's all. I think it's so trivial. Okay, let's solve the following one. Look with me here. By the same way, I know the exponent above what? Or the exponent of the function. I can rewrite it 1/4, this constant. Sine 2 theta all to power 2. The derivative of this function, it will be the derivative of the bracket multiply the derivative what inside the bracket. It will be 2 multiply 1/4. Okay, the bracket sine 2 theta all to power 1 can be submitted. Multiply the derivative of inner, which is what? Composite function. That is what? The inner function of this composite function, which in the bracket. The derivative of sine will be cosine, but cosine what? What is the input? 2 theta. Okay, multiply the derivative of LU, which is what? 2. So it will be 2 multiply 2/4, the number, multiplies the number together. 2 multiply quarter, multiply 2, it will be 1. Okay, sine 2 theta multiply cosine 2 theta. Trivial. Okay, here. I think number 8, so trivial. Pi is constant. Pi is constant. Let's solve another example. Here, question number what? 9. Okay, look here. Yes. Miss here, this function, how to find this one? I need to write this one to be in power and apply the power rule. This one miss here. I squared the angle. Here, the squaring of angle. I have to find the squaring of the angle to know how to get its what derivative. So I rewrite this function, square root x, it will be x to power half. Okay, I think all of you know how we write. Plus 1 over 4 sine. What is the angle? I have to find the squaring of this angle. That is the squaring of angle, not the squaring of function. Distribute, it will be 2 to power 2, it will be 4. Okay. X to power 2, it will be x what? Square. That is the rewriting of function. Then find the derivative. How we get the derivative? Find the derivative of this one. Apply what? I have to identify which rule I'll use. That is depend on the given function. Okay, and you have to know how to apply it. Yes, power half x decrease x1 by 1 negative half. Yes, I know how we get it. I know how I get this answer. Plus 1 over 4 multiply. What is the derivative of this function? It is a composite function. The derivative of outer, that is my u, the inner function. So it will be cosine u, which is 4x squared. Look here, sine u. The derivative of sine u, it will be what? The derivative of sine cosine u multiply u prime. Just apply the rule. Derivative of outer of the derivative, the outer function, add the inner function. Okay? Multiply the derivative of u, which will be 8x. Okay, rewrite it to be in the simplest form. It will be here. I write this one in the denominator. It will be 1 over 2. X to power half, in the middle, it means root x. Understand? Here means I multiply this one by this one. It will be what? It will be, wait a minute. I'm sorry. Plus this one together, multiply this one with this one, never to multiply with the angle. Okay, I multiply this term with this term first. It will be what? 4x cosine 4x squared. Understand? It is so trivial. Have you understood? Before you begin to solve number 10, I prefer to pause the video, as I told you before, okay? Here, I need to rewrite this one after I find the squaring of the angle. It will be 3x. If you have a square of the angle, I have to find the squaring of the angle before I apply the rule of differentiation. If you have a square of, the trigonometric function raised to exponent, I have to write it between two brackets. Then apply the general power minus 5 cosine squaring of this 4 squaring of x, it will be x squared. Then now I apply the basic rule of differentiation. What is this one? 3, it is a linear. This one, it will be the constant, multiply the derivative of this function. How we get it? That is u. Apply the rule. It will be the derivative of outer at u, then multiply the derivative of u. It will be, what is the derivative of the outer? Negative sine x squared. That is the derivative of outer, and this is u as here. Okay? Multiply the derivative of what? The angle, which is what? What is the derivative of this one? Apply the power rule. It will be 8x. Okay, then simplify. It will be 3, multiply negative 5, multiply negative 1, multiply 8x. It will be what? Plus 40x sine 4x squared. I have to multiply this term with this one, Multiply the coefficient, but don't multiply any number or anything by the input of the trigonometric function. Okay, -5 multiply -1, it will be +5. Multiply 8, it will be 40. X, then sine 4x square. Okay, let's solve the next one. Oh my God, yes, here that is what? U. How I find it? This, it's so easy. This implies the derivative of this function, it will be the derivative of outer, which will be cosine. I tell you which is what? Cosine x. Okay? Multiply the derivative of u, which is what? Negative sine x. So your answer, it will be cosine what? Cosine x. That is the angle of this one. So it will be cosine, the derivative of outer at u. It will be sine. The derivative of sine, it was cosine. Understand? What is u? Cosine x. Multiply the derivative of the inner function. So it will be negative sine x cosine x. Okay, just apply the ruler. So I think that the next one, it will be the last one, I think. No. This one, as I solved it before, repeated. It is repeated. Okay, let's solve the next one. Maybe it will be long, but it will be easy. Okay, look with me. That is u. Repeated application of the chain. The derivative of outer, it will be what implies the derivative of outer, it will be cosine. Cosine what? U. Which is what? U tan 2x. I just apply the rule. Keep the rule with you to know how I get it. Multiply the derivative of the angle, as you see here. What is the derivative? It is a composite function. Then repeat the chain rule again. So it will be what? What is the derivative of outer? It will be what? Secant. That is u of this composite function. Secant square of u to x. Multiply the derivative of this u. It will be 2. It will be here 2 secant square 2x multiply cosine of tan 2x. I hope you understand, okay? That is these example to not 12 but 11 and 13 repeated application of the chain. Thank you. Have a nice day.